All right, here we go. Problem 5-13. Sketch the solution of this system of inequalities. We have y is greater than or equal to x squared minus 5, and we have y is less than or equal to the opposite of the quantity of x minus 1 squared plus 7. So they're asking us to go ahead and graph them. Now I'm going to do it without the calculator. I'm going to actually graph them right on here. So as we look at it, the first part of this, we want to make sure we just go ahead and think about it like it's the regular equation. Don't worry about the inequality part of it here as we map out the points for our parabolas. Remember, our locator point for parabola is going to be the point HK, and it's our vertex. So for my first parabola here, I should have a point 0, negative 5. So I'm going to have 0, negative 5 right here. And I have a value for my a is 1, so it has the standard shape of a parabola. So we've taken our parent function and we've just translated it down 5 units, which means I can use my y-axis as my axis of symmetry, and I know that it has that standard growth. So I know if I move 1 to my right, then I have to move up 1 squared. If I move 2 to my right, I have to move up 2 squared. So I'm going to go up 4. 1, 2, 3, 4. If I go 3 to my right, I'm going to go up 3 squared, which is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's go the other way here. So we're just going to reflect it across the y-axis, because that's our axis of symmetry. I'm 2 away, so I'm 2 away. I'm 3 away, so I'm 3 away on this side. So we've got our parabola that's opening up. We're going to talk about actually whether or not it's a dashed or a solid line and where the shading goes in just a moment. I'm going to plot my points on for both of them first. So for my second one, I have y is less than or equal to the opposite of x minus 1 squared plus 7. My locator point on this one is still going to be hk. So remember, we have x minus h and plus k, so our locator point is going to be the point 1, 7. So we're going to have our vertex at 1, 1, 2, 3, 4, 5, 6, 7, which makes sense because this one opens downward because of the negative a. So let's go ahead and plot our points. It's got the typical parent function growth pattern as well. So we're going to go over 1, down 1. We'll go over 2 and down 1, 2, 3, 4. Move over 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can reflect that across our axis of symmetry here. So we're going to go 1, 2, 3, and we're going to go back 1, 2, 3. We're going to go over 1, 2, then we go over 2 more. And we go over 1 and over 1. Now because both of these parabolas in their inequalities have equal signs here, I'm going to be able to go ahead here and draw in my parabolas, and they're going to be solid. So let's do that right now. I'm going to take it here and I'm going to graph, and I apologize if these aren't real straight or real perfect here. It's hard to graph with this program. And I'm going to go the other side here. Ain't too bad. I'm happy with that. And we're going to go ahead and do our other one now. So I'm going to go upwards. So I've got my two parabolas graphed. Now let's talk a little bit about the solutions to the inequality parts of it. So I'm going to get out something to do a little bit of shading. You should as well. I like to use crayons here, so let's do red with our red one. So we have y is greater than x squared minus 5. So we're thinking about all the outputs that are greater than our x squared minus 5. So think about this. This is our x squared minus 5. This is all of our points here that represent that function. If I want the output values that are greater than or equal to that, well, we've got the equals part already taken care of. But if I put my pencil on the graph of my parabola and I want to talk about something that's greater, I would want to move up. So that means that this side of my red parabola is going to be the greater side. So I'd want to take it here and I can shade it in here. Just going to shade it lightly. I don't want to get all carried away. I do want it to be pretty though. Alright, so I failed coloring in school. Don't be mean about it. There we go. That's close enough. So this is representing all the solutions to our y is greater than or equal to x squared minus 5. Let's look at our y is less than or equal to the opposite of the quantity of x minus 1 squared plus 7. So we're going to go in here. Let's change to our different colored crayon there. All right, now, if this represents all of the values that are equal to the opposite of the quantity of x minus 1 squared plus 7, and we want all our y values that are less than that, if I can put my pencil on it somewhere and I can just move it straight down, remember, the outputs that are underneath it are less. And that's what we're looking for. So it's going to be pretty much everything inside of this one. Now you don't have to do all this shading right now. You can just shade your final answer. I know that I allow my students to do that, but I want them to at least think about it and find the correct answer before they just go on there and, make pretty pictures and stuff. So the solution to the system is going to be where these solutions overlap between the two different parabolas. And you can see very clearly that this is where the overlap is in here. So I'm going to take it here and I'm going to just use a different color. Let's see, let's do something like, how about a nice purple? There we go. And I'm going to just emphasize here that this is my solution to the system of inequalities that we have in this problem. Like I said, if you just want to shade only the solution here, that's okay, that's appropriate. But make sure you don't miss anything. Make sure you stay in the lines too. I was struggling there a little bit. All right, so here is our solution. Last thing though, I want to check to make sure it's right. So what I'm going to do is I'm going to choose a point that lies in here, okay, in both of the solution sets there, and I'm going to plug it in to make sure it's true. And the best number I like to use here, or the best point would be 0, 0 when it's available. So it does fall in the shading for both of these parabolas or both of these functions. And let's plug it in to make sure that they are true. So the first one here, we're going to have 0 is greater than or equal to 0 squared minus 5, which then we get 0 is greater than or equal to negative 5. That is correct. Plug it into the second one. 0 is less than or equal to the opposite of 0 minus 1 squared plus 7. Well, we got 0 is less than or equal to. 0 minus 1 is negative 1. Negative 1 squared is 1, but then we're going to take the opposite of it again. So we have negative 1. Negative 1 plus 7 is 6, which is also true. So our solution appears to be correct. This is problem 5-13. Hopefully that was helpful. If you needed assistance or if you were just checking your answers, you can see where our solution is. If you have questions, make sure you ask your teacher. Otherwise, this is Mr. Boyd signing off.